Okay, so this is going to be our final day of exploring periodic data. We're going to wrap up this section, and then tomorrow you are going to turn in all of your class notes and take a quiz over periodic data. So at the top of these notes, I've just put a reminder of our key terms for this week. So we've talked about what a periodic function is. We've talked about a cycle, how to identify a cycle, how to calculate the period, how to calculate the amplitude, and how to find and write the equation for the midline. So the period, midline, and amplitude are all pieces of a periodic function. So if you need to remind yourself what all these big fancy words mean, go ahead and review those key terms now. So let's jump into example 1. So in example 1, we have this cool little graph, and it looks like it's rooted in a word problem. So let's go ahead and read that. Sound is produced by periodic changes in air pressure called sound waves. The yellow graph in the digital wave display shows the graph of a pure tone from a tuning fork. What are the period, equation of the midline, and the amplitude of that sound wave? So this graph right here represents the perfect pitch that's made from a tuning fork. And so this is... Sorry, just got interrupted by my dog barking. Apparently he saw that super duper evil squirrel that likes to hang out in his backyard, so he has to go chase it. All right, so getting back to this problem, we have a yellow graph that we're looking at, and that came from the sound that a tuning fork made. This is the sound wave. So we're going to identify the period, equation of the midline, and the amplitude. All right, so to identify the period, we first have to identify a cycle. So when I talk about finding a cycle, I'm talking about finding the pattern that's repeated over and over and over again. So for example, if I look here, and when I identify a cycle, I also want to make sure that I begin with and end with the same y value. So I have a y value of, what is this, 1.5 here, and then it looks like my sound wave goes up and then comes back down to 1.5, and then it looks like it starts at 1.5 again, goes back up, comes back down to 1.5, so there's another cycle, and then another cycle starts at 1.5, comes back down to 1.5. So you can see that we're starting at that same y value and ending at that same y value. So this is a cycle, this is a cycle, and this is a cycle as well. So the period is the horizontal distance of a single cycle. So to look at the horizontal distance for the period, we need to look at our x values. So our x values, it looks like we start at 0, and then we're going to subtract the larger x value here. We're going to take it. They're counting by 0.004, and that's 0.008. I'm assuming this is 0.006. Hopefully you guys agree with me. So we're going to take the larger number, 0.006, and subtract 0, and that would be 0.006. So our period is 0.006. Then if you recall, to calculate the amplitude, so the amplitude is equal to 1/2 times your maximum value minus your minimum value. So I'm going to erase these markings so they're not in my way. It looks like our maximum is here and our minimum is here. I'm going to say that maximum is 2.5 and the minimum is 1.5. So our amplitude is going to be equal to 1/2 times 2.5 minus 1.5. 2.5 minus 1.5 is 1, so half of 1 is equal to 0.5. So our amplitude is 0.5. So to find the equation of the midline, we need to move up 0.5 from our minimum or down 0.5 from our maximum. So if I do that, if I start at my minimum and I go up 0.5, I'm going to be at 2. If I go down from 2.5, I'm going to be at 2 as well. So I would say that our midline is the equation y equals 2. And that checks out because 2 is 0.5 away from the maximum, and it's also 0.5 away from the minimum. So it matches our amplitude. So our midline is y equals 2. All right, so why don't you go ahead and pause the video and do example 2 on your own, and then unpause the video and check your answer with me when you're done. All right, so this time we're looking at the second graph, this lovely little thing, and you should have found your period, amplitude, and midline. So let's walk through this together. To find my period, we need to first identify a cycle. So remember, whenever we identify a cycle, we want to start and end with this same y value. So I'm going to start with, I'm going to do my cycle from this point to this point, because I see a pattern happening from here to here, and then that would have also happened through there, and it'll continue happening on and on. Okay, so I am going to identify those x values to find my period. So my x value, I'm starting with 0.008 as my least value. And then if this is 0.12, let's see, this would be 0.0010, right? 0.012. So this would be 0.014. Hopefully I'm right. So what is 0.014 minus 0.008? I believe that is 0.006. And I'm just going to double check that before I send this video out to all of you. 0.014 minus 0.008 is 0.006. Very good. All right. So then our amplitude. So to find our amplitude, remember your amplitude is equal to half times your max minus your min. It looks like our maximum is, if this is 0, so this is 0.5, negative 0.5. And then our minimum is negative 1, minus negative 1. So what is negative 0.5 minus a negative 0.1? Positive 0.5 divided by 2 is 0.25. Or multiplied by a half is 0.25. So our amplitude is 0.25. So we need to start at our maximum and go down 0.25, and then start at our minimum and go up 0.25 to find our midline. I'm just going to erase this stuff for a minute. So to find my midline, let's use yellow. We're going to start at our maximum and go down 0.25. So from negative 0.5 to negative 1, negative going down 0.25 from negative 0.5 would be negative 0.75. And then from negative 1 up 0.25 would also be negative 0.75. So that tells me that my midline is at y equals negative 0.75. And hopefully that matches what you guys got. All right, I'll talk to you later.